So we're going to continue our study of the normal distribution. And before we get into the new notes for today, I'd like you to quickly go back to page 24, or just watch what I'm about to do right now. I just sort of want to show you where we're going with this stuff. In the last class, we looked at the empirical rule to figure out what percent of people lie within a certain region. So on page 24, we were looking at adult IQ scores. And in part B, I asked you what percent of adults had an IQ between 70 and 115, for example. And we did that by just adding up our sections over here. The problem with using the empirical rule is that only works if the numbers I'm asking you to deal with happen to be those specific tick marks we have on our x-axis, the mean, or 1 standard deviation from the mean, or 2 standard deviations from the mean, and so on. If I wanted you to do a problem like what percent of adults have an IQ between 90 and 108 or something like that, things that aren't good tick marks here, our empirical rule isn't going to work. There are some other tools we're going to need to use. Today is going to be all about building up those tools, and then we'll see how to apply those tools to questions like what we have here in letter B, just with numbers that aren't those good tick marks that we see from our empirical rule. Today we're going to build up the tools. Next class we'll see how to put all this stuff together. I'd like to go to page 28 in the notes. We're going to talk about this thing called the standard normal distribution. And a standard normal distribution is a normal distribution with a mean of 0 and a standard deviation of 1. The standard normal distribution is a normal distribution with a mean of 0 and a standard deviation of 1. So I went and I put tick marks on my x-axis over here. I've got my mean of 0, then I have 1, I have 2, I have 3, negative 1, negative 2, negative 3. And the whole point of this standard normal distribution is this lets us talk about problems like the IQ problem, not in terms of exact IQs, but in terms of things like what percent of our data is less than 1 standard deviation above the mean. What percent of data is less than 1 standard deviation above the mean? So what percent of data is here? And everything less than that. Or what percent of data is less than 0.7 standard deviations above the mean? What percent of data would start here and be everything less than that? And stuff like that. Here's how we're going to deal with the standard normal distribution. On the bottom of the page, letter A is asking us P of z is less than 1.5. What this is actually asking us is what percent of data is less than 1.15 standard deviations above the mean. What percent of data is less than 1.15 standard deviations above the mean? So, looking at my particular normal distribution over here, let's see, my mean is 0. I've got a tick mark here at 1.15. I want to figure out what percent of people are in this shaded region. That's nothing that I'm going to be able to do with my empirical rule, so we need a new tool called our standard normal table. Flip to the next page in the notes, page 29 and page 30. The crazy looking table you have here with lots of numbers. This table tells us the percent of data, as a decimal, that is less than our particular z value. Let me write that down. That table, that standard normal table, the numbers in the table tell us the percent of data as a decimal that is less than z. Our standard normal table tells us the percent of data as a decimal that is less than our particular value z. So in letter A, I want to figure out the percent of data that is less than a z value of 1.15. I can use the table to figure that out. Here's how I can do that. The rows give me the number before the decimal place and the number in the tenths place. The columns give me the number in the hundredths place. You know what? I don't actually want to be on page 29 right now. I want to go to page 30 because if you look at page 29, all of our z-values here are negative, and I want to figure out the percent of data whose z-value is less than positive 1.15. So I'm going to flip to page 30 where I have positive z-values. I'm going to go down to the row for 1.1. Then I'm going to go over to my column for 0.05, because if you put those two ideas together, we get 1.15. What percent of data are we talking about? Well, according to the table, that's 0.8749. Back on page 28. How am I doing part A? I'm looking at the row for 1.1 and the column for 0.05. That gives me 0.8749. But I told you that the table would give us the percent of data as a decimal. I want to turn this into a normal looking percent, so I'm going to write that as 87.49%. 87.49% of my data is less than 1.15 standard deviations above the mean. 87.49. Let me show you how to do a couple more. I want to figure out the percent of data whose z-value is less than negative 0.24. Well, this time we're going to go to the negative side of the table, page 29. I'm going to look for the row that is negative 0.2. Oh, you know what? I've got to be able to show you the whole table. I want to find the row that's negative 0.2, and I want to go over to the column for 0.04. I'm going to pick out this number right over here, 0.4052. What am I looking at to do letter B? I'm looking at the row that's negative 0.2 and the column that is 0.04. That gave me 0.4052. Turn that into a percent. You're going to get 40.52%. See if you can go do letters C and D. Pause the video and see what you can do in C and D. Letter C, I'm going to look at the row negative 2.1. I'm going to go over to the column for 0.09. That's going to give me 0.0143 or 1.43%. In letter D, I'm going to go to the positive side of that table. I'm going to go to 2.1 rather for the row, and the column 0.07. We're going to get 0.9850, and I'm going to call that 98.50%. I realize this might seem a little bit abstract right now. Right now, I think we're just going to focus on being able to pull these numbers out of the table. In the next video, on the next day, we'll see how this stuff can be used to figure out, again, going back to that IQ question, what percent of people have an IQ between like 98 and 108, things that weren't good tick marks that we could use our empirical rule for. So the whole point of that standard normal table was it told us what percent of data is less than some particular z-value. But sometimes I care about what percent of data is greater than a particular z-value, or maybe what percent of data is in between a couple z-values. We can still get this information from the table. It's just going to be a little bit more involved. So I'd like you to hold on to that table. We're going to come back to that in a moment, but I want to go on to page 31. There are various types of areas we could be looking for. We could find area to the left of a particular z-value. We already saw that. Area to the right of a particular z-value. Find the area between that. Find the area of that, or the area between two z-values. you know what? I think I actually want to jump between page 31 and 32 as we go to do these things. Let's take a look at page 32. In letter A, I want to find the percent of data whose z-value is less than negative 0.99. This is nothing new. This is exactly what we did on the previous page. The difference is the direction says draw standard normal distribution. We use the area ideas and all that stuff. Well, I'm going to start by just drawing my normal distribution. I'm going to put in my mean, which is 0, and I'm going to put in a tick mark at negative 0.99. I know negative 0.99 has got to be to the left of 0, so about there. I want to find the percent of data in this region over here. Well, you know from what we just talked about that that comes directly from the table. We just look at our table and pull the number out of there. Let's go back to page 31 for a moment. Anytime that I want to find the area to the left of a particular z-value, all I do is just find the percent in the table. That's all I'm going to do. So if I have something like this with a z-value over there, I'm just going to look up that z-value in the table, and it will give me exactly what I'm looking for. On page 32, what percent of data has a z-value less than negative 0.99? Well, let's go to our table. Negative 0.9, and go over to the column 4.09. I think that's looking like 0.1611. Which I'm really going to call 16.11%. This really is not any different than what we've done before. The only reason I'm doing this on this page as well is to give you something to compare C, D, and E, F to. Take a moment, quickly do letter B. Really no different than what we've been doing. I'm just going to start, though, by drawing that normal distribution. I do want to put the mean, and my z-value has to be greater than that. I'm looking for what percent of data is over here. Go to your table, make sure you're on the positive side this time, page 30, not page 29. I'm getting 98.34%. In the next problem, letter C, I want to find the percent of data whose z-value is greater than 1.06. Well, I'm going to sketch this. That's 0. This one's 1.06. This time I care about greater than 1.06, so I want to know how much data is over there. This one I can't get directly from the table. The table would tell me how much data is less than 1.06, but this time I want to know more. There's a trick we can use. To find the area to the right of a particular z-value. Let's say I want to figure out this area over here, what percent of data is over there. Well, I can use the table to figure out what percent of data is to the left of the z-value. I'm going to start by saying use the table to figure out the percent of data to the left of z. So I could figure out this thing from the table. Well, because the total percent of data underneath this normal distribution has to be 100, I can just do 100% minus this percent to give me the percent over here. Since I'm working with this as a decimal, I could do the calculation 1 minus the area to the left of z. If I figure out that like 25% of the data is over here, that means 75% of the data is over here. And the whole 1 minus thing, we would have gotten 0.25 from the table. 1 minus 0.25 would give you 0.75, this percent as a decimal. So let's see how to use this. Over here, I want to find the percent of data greater than 1.06. Well, I can use my table to figure out the percent of data to the left of 1.06. Go to your positive side. 1.06 should be 0.8554. How much data is over here? 85.54%. I'm going to do the calculation 1 minus 0.8554. Go to your calculator to do that. That's 0.1446. So how much data is greater than 1.04? 14.46%. I've got to see that subtraction problem. I've got to see you're subtracting what was in the table from 1. You go try letter D. Sketch your normal distribution. So negative 2.16 is over there. So I care about all this. Oh, this should be a pretty big percent because it's so much of that normal distribution that's getting shaded in over there. Go to the negative side of your table. I think you should be finding that 0.0150. No, hold on. I think I got that wrong. Nope, sorry. 0.0154 of the data is over here. So I'm going to do 1 minus that. And I'm going to come up with 0.9846, or 98.46% of the data is in our shaded region. We have one more variation we need to look at. In letter E, I want to figure out what percent of the data has a z-value between negative 1.5 and 1.25. I'm going to draw my normal distribution. 0 is in the middle. Here's a tick mark of negative 1.5 and another one of 1.25. I'm going to shade the region I care about. I care about the region over here. Let's talk about how to do this. Go back to page 31. Let's say I want to find the area in between two particular z-scores. I'm going to call one of them z1, the other z2. I want to find this area over here. Well, I'm going to start by finding all of the area to the left of z2. I'm going to find all the area to the left of z2. I'm going to figure out this whole thing over here, which I hope you're realizing is a little bit too much. I need to take away the area to the left of z1. Well, I can go find that area. And then I'll subtract. I'm going to find this pink area, but that's too much. I'm going to take away the blue area that I shaded over here, and I'm going to get exactly what I want. I'm going to get the area between those two z-values. So on page 32, I want to first find the area to the left of 1.25. Go to your standard normal table. To the left of 1.25, well, that's looking like 0.8944. Then I want to take away the area to the left of negative 1.5. Find that in your table. Negative 1.50. That would be minus 0.0668. Go do your subtraction. That should give you 0.8276. So about 82.76% of our data will be between those two z-values. You try letter F. Make sure you're being good with your drawing. Realize both of these z-values are negative, so they both had better be to the left of 0. Care about maybe the area over there. I'm going to do 0.0885 minus 0.0154, 0.0731, which is giving me 7.31%. My hope for today is that you see how to do the calculations. Maybe you don't necessarily see why we care about them. I don't think you necessarily would see why we care about them yet. In our next class, we will see how we can apply these calculations to those real-world problems to figure out what percent of IQs are between, well, 2 tick marks that weren't good for us to use the empirical rule for. That's where we're going. In the homework, make sure for each problem you show your standard normal distribution and show the shading of your region that we care about. In a problem that's a less than problem, you're not really going to have any work. You're just going to take that value straight from the table. In a greater than problem, I have to see the work. I have to see you subtracting what was in the table from 1. And in a between problem, like what we had in E and F, I need to see one value from the table minus another value from the table. So I do need to see work. Not a lot of work, but I do need to see those calculations.